Learning Simplified. My name is Eric. I'll be taking you through this topic, squares and square roots, and for this lesson we're going to look at the squares of numbers by factorization method. So we'll see how we use factorization method to find the squares of decimal numbers. Previously we used the same method to find the squares of whole numbers. Now we want to use it, the same approach, to find the squares of decimal numbers. And we have sample questions on the same to help us see how that can be done. And of course, at the end of the lesson, we'll be able to give you some questions just to help you interact more with the content, and of course just to help you practice as you try to learn this method called factorization method of finding the squares of numbers, and basically and specifically decimal numbers. So we have a few examples here. I want to see how you can find the squares of these numbers by factorization method. So we have looked at a number of methods before. So this is not the only method that you can use. We have multiple methods that you can use to help you find the squares of these numbers. So let's see how we use factorization method to find the squares of decimal numbers. So what you'll do is, one, we have 0.4 squared. So what you're going to do is to write this number as a fraction, with the base being written as a power of 10. So we have 4 divided by 10. So you just check the number of decimal places, or check the last digit and use the place value. Like the last digit here is for what's the place value? Tenths. So you divide by 10. Tenths is interpreted to mean 1 over 10. So instead of 1, we have 4 over 10. Then now you try to express both numbers as a product of their prime factors. Remember, previously we moved the decimal point to the left, a number of steps that is equivalent to number of zeros here. So we will not go that direction now. We will just try to express all the numbers as a product of their prime factors in power form, or a product of their prime factors. For example, here we have 2 by just a minute here. So before we do that, this one here is squared, So if you square that, you'll get 4 by 4, and also squaring this will be 10 by 10. So remember, 0.4 is what we are writing as 4 over 10, and then you square that. So if you square that, is 4 by 4 and 10 by 10. So as a product of their prime factors, we have 2 by 2, and then a 4 again by 2 by 2. So the first 4 is 2 by 2, and the second 4 is 2 by 2. Again, 10 is 2 by 5, and the second 10 here is 2 by 5 again. So 10, 2 by 5, another 10, 2 by 5. So you cancel out. So these 2 crosses that 2, these 2 crosses that 2. So what we have remaining is these 2 here by these 2. So 2 by 2 over 5 by 5. So answer is 4 divided by 25. So we have used prime factorization to help us arrive at this 4 over 25. So you can still leave it in that form. That is still a correct answer. If you want to change it to a decimal, we have explained in our previous videos how that can be done, how you can convert this back to a decimal by using long division method. So again, you have 0.25 squared, that is for this one here. So we have 25. The last digit here is, what is the place value of the last digit? 5 hundredths. Remember, for these digits after the decimal point, we state their place values starting from the first digit here, and that starts with tenths, then hundreds, then thousands, and so on and so forth. Again, we've done videos on the same. You can check from our previous videos, you'll be able to see how that can be done. So this is 25 over 100. This is squared. So that is 25 by 25. And then you also square 100 times 100. So now 25 will be 5 by 5 as a product of its prime factors in okay, just that. And then we have 5 by 5. And then now 100 we have 2 by 2 by 5 by 5 by 5. Again 100, 2 by 2 by 5 by 5. If you don't know how that is done, we've done a video on that. Again, you can check, but simply we have 100, use factor tree. So 2 goes into 150 times, 2 goes into 50, 25 times, and 5 goes into 25, 5 times. Then you just multiply these prime factors. That's what you're doing here. So again, you will try and cancel out the prime factors that are common. For example, here 5 will cancel 5, this 5 will cancel the other 5. We have this 5 cancelling that, and 5 cancelling the other 5. So our answer in the numerator is going to be 1, because all of them, remember, all of them divided by 1, 1. But now down here we have 2 by 2, this, and we also have that by 2 by 2. So what do you get if you do that? So that is going to be 1 over, the first 2 here is going to be 4, and the other 2 are going to be 4. So we have 0.25 squared being equal to 1 over 16. So again, 1 over 16, you want to change it back to a decimal. You should be able to do that without much struggle. So again, we have 0.24 squared. So that is going to be 24. The last digit of the decimal is, the place value there is 100. So I'll divide by 100. And this is also squared, so that is going to be 24 by 24 divided by 100 by 100. So you try to express these numbers as product of their prime factors in power form. So 24, we have 2 goes there 12, 2 goes there 6, and 2 goes there 3. So that is going to be 2 by 2 by 2 by 3. The same again to the other 24, 2 by 2 by 2 by 3. Down here, I also have 100, so I try to express 100 as a product of its prime factors. So again, 2 goes there 50 times, 2 goes there 25, and 5 goes there 5. So you just multiply this. So we multiply all the prime factors. So we have 2 by 2 by 5 by 5. Again, 2 by 2 by 5 by 5. So the first 100 is 2 by 2 by 5 by 5. The second 100 is again 2 by 2 by 5 by 5. Then you cancel out. So 2 goes cancels 2. The other 2 cancels this 2, and this 2 cancels that 2. You see, that is all. So the numbers remaining in the numerator, will just multiply them. So that is going to be 3 here by, there is 2 here, there is another 2, and finally there is another 3. Numbers remaining down here, we have 5 and 5, and we have another 5 here, and you have another 5. So down there we'll multiply 3 by 3 to give me 9, and 2 by 2 to give me 4, 5 by 5 to give me 25, and 5 by 5 to give me another 25. So we have 0.24 squared equals to 36 divided by 625. So that is still equivalent to the square of this one here, the square of 0.24. So you can decide to express it as a decimal. You should be able to get the same as when you use the other approaches. The same answer we got when we used the other methods. So we also have one that now we are using the symbols. So we have the symbol is power 8. So that is still the same as 8 over 10 squared, which is 8 by 8 over 10 by 10. As a product of their prime factors is 2 by 2 by 2, that is 8. Again, 2 by 2 by 2, 8 again. So we have 2 by 5 is 10, and 2 by 5 is 10. So this cancels this, and this also cancels that. So the numbers remaining in the denominator, the numbers remaining up here will be 2 by 2 by 2 by 2. Down here we'll have 5 by 5. So 2 by 2 is 4, and 2 by 2 again is 4, and down here we have 25. So up here we have 4 by 4, 16 over 25 as the correct answer. So again you have 0.09 squared. So the last digit is 9. The place value is hundreds. So you have 9 over 100 squared, which is going to be 9 by 9, 100 by 100. So as a product of their prime factors, we have 3 by 3, and we have 3 by 3 again. So this is 2 by 2 by 5 by 5, again 2 by 2 by 5 by 5. So here, unfortunately, it's not possible to simplify. So that is just going to be again 9 by 9, and down here we'll have again 100 by 100. So it's not possible. So you see that is going just to be 81 divided by 10,000. So again you have 0.24 squared. Again, this is 24. The last digit here is 4. Place value is 100. So you divide by 100 square. So that is 24 by 24 divided by 100 times 100. So up there we have 2 by 2 by 2 by 3. That is 24. 8 by 3 again. 2 by 2 by 2 by 3. So 2 by 2 by 5 by 5, that is 100. Again, 2 by 2 by 5 by 5, that is 100. Try to cancel out those that can be cancelled. So 2 cancel this, 2 cancel that, 2 cancels this, 2 cancels that. And that is all. So it's just a matter of multiplying the numbers remaining in the numerator, which is 3 by 2 by 2 by 3. That is this 3, this is 2, this is another 2, and this another 3. Denominator we have 5 by 5 and by 5 by 5. So 3 by 3 is 9, and 2 by 2 is 4. 5 by 5 is 25, and 5 by 5 is another 25. So 9 by 4 is 36, and 5 by 5 is 625. So still you can be able to prove that this, if converted back to decimal, will still be the same as the one we obtained when we were using the other methods. Yes. So that marks the end. We have some few questions here to help you practice on the same. That is using this other approach. I've looked at about 3 approaches in the previous video. You can check this approach as well. So if you are asked such questions in the exam, you can always use any of the approaches that you have looked at, depending on which one you find easier to use and which one is convenient as at that particular time. So a few questions are here to help you practice on the same concept, just applying the same method or using the same method to see whether you'll be able to arrive at the same answers. Otherwise, that marks the end. Until next time, goodbye.